Hey guys, this is 6.4 logarithmic functions. In 6.3, we talked about examples of exponential functions where the variable is in the exponent, like 2 to the power of x equals 8. And we try to imagine how to solve for x, right? And in that case, it would just be x is 3. But if we had 2 to the power of x equals 5, I can't really find the answer, right? So today we are going to learn about logs or logarithmic functions that will help us to solve exponential functions, and then exponential functions can help us solve logarithmic functions. One second. Okay. The inverse of an exponential equation is a logarithmic function, right? So logarithmic functions are the inverse of exponential equations, and logarithms undo exponents, and exponents undo logarithms. Okay? If log base A of x is what undoes 2x equals 5, then I need to learn how to convert between the logarithmic form and the exponential form. Okay? Log base A of x, y equals log base A of x if and only if x equals a to the power of y. Okay. Logarithmic functions are the inverse of exponential equations. You cannot take the log of a negative number, so the domain, all the x's have to be positive. Okay. So basically, x equals ay becomes y equals log a of x. So we have exponential form and logarithmic form. And we're going to convert or switch back and forth between the two. So let's start with 2 power of x equals 8, right? And let's just label these. 2 is our base, x is our exponent, becomes log base 2 of 8 equals x. So this is still called the base. Okay. The exponent moved over here, and the answer moved over here. These are the same. So this is the same as. Okay. One more time. 2 to the power of x equals 8 becomes log 2 of 8 equals x. And what Miss Walters did was start with the base 2 and move in a circle. 2 x 8 x 2 8 x. Okay. So we have 3 opportunities up here to practice converting. We're not solving anything, we're just converting. So we have 1.6 to the third equals w. And if you want to, just go in a circle. Okay. 1.6 to the third equals w becomes log Start with your base. Our base was 1.6. Go in a circle. Next we have W. And finally we have 3. Okay. If e to the power of u equals 25, then log, start with the base, e of 25 equals u. Okay. If b to the 5th equals 27, then log, start with your base, b, go in a circle, 27 equals 5. Now we're going to convert to exponential form, and you can still go in a circle. So start with your base, b to the 3rd equals 8. So we're starting down here. E to the -2nd equals c. We're just going in a circle. E to the -2nd equals c. 4 to the w equals 4 to the power of w equals 6. Good. That is our first set of skills. We know now how to convert between exponential functions and logarithmic functions, right? And then logarithmic functions to exponential functions. How can I use this to evaluate logarithmic functions, right? Find the exact value by converting to exponential form. On, I don't know how to do that on a calculator. On a Texas Instruments calculator, you should be able to go to Alpha and then press Window. Yeah. It's called Table Set, and go to number 5, log base, and it will allow you to put in a base. So we can just copy this one. Log base 3 of 81. Yeah. And the answer is 4. If your calculator does not have the window button, and it's called the table set, it doesn't look like that on mine, but yours will say table set. If it doesn't have that, you can, but if you do have this button, you can use this button. So if you just take log, you can still do it. So that's not going to give me 4, right? But that is the log button without the option to add a base, because it automatically is a log base 10. So just to show you. Log base 10 of 81 will include that. That's just a given 10. But because the base 10 is the common log, but the change of base method allows us to use log base 10 to determine what log base 3 of 81 is. What you do is you take the log of 81 and then you divide it by the log of 3. And that gives you 4, which is the same as 3 of 81. Good? All right. So the log base 3 of 81 can be rewritten as the log of 81 over the log of 3. Good. The log base 5 of 1 over 125 can be rewritten as the log of 1/125 divided by the log of 5. Good? So the exact value of these are log 1/125 divided by log 1/5 is -3. So that one was 4, and this one is -3. Okay, but it says find the exact value by converting to exponential form. So that was one way to solve it with our calculator. Or we can convert to exponential form. So remember, we start with the base, log base 3, and then we say x equals, right? Because we're going in a circle. 3 of x equals 81. Let me rewrite that. Log 3, 81, right? And it says convert to exponential form. And here we said B3, 8, right? We went in a circle, so we need the equal sign. And then we need something after the equal sign. Here we have a 3. Here we don't know what it is, so I'm just going to put x, right? And I'm going to do that same circle. 3x 81. So 3 to the power of x equals 81. Log 5, 126 equals x. So that becomes 5 to the power of x equals 1/125. Yeah, and then you think, 3 times itself, how many times will give me 81, right? 3 to the second is 9. 3 to the third is 3 to the fourth is 81. So x equals 4. Good. Now 125. 5 to the second is 25. Sorry. 5 to the third is 125. But it's down here. Yeah. I think that means it's 1/5 to the third, right? And if I want that to not be a part of a fraction, I move it to the other side of the fraction bar and change from a negative to a positive, or a positive to a negative. I make it the opposite, right? So that's 5 to the negative third. Let's try it. 5 to the negative third is 1/1. Negative 3. So x is negative 3. You can solve it using your calculator, or you can solve it using logic and what you know of exponents. All right. Now on your calculator, you have the log button, which we discussed has an understood base 10, right? So if I just said log of 100, that is the same as saying a log of 100 divided by the log of 10, or log base 10 of 100. Yeah. Log 100 is 10. Sorry, it's 2, because 10 to the power of 2 is 100. It's called the common log. The other type of log that is used very often is called the natural log, and it's ln your graph. Yeah, and it means log. So common log is log base 10. Natural log is log base e. Remember we learned about in our last lesson. So how do I solve logarithmic equations? We convert them to exponential form, right? Number one, log base 5 of 3x minus 4 equals 3. Okay, so I'll rewrite that down here. Let's say this is number 1. This is number 2. This is number 3. And this is number 4. We're just going to practice going back and forth between logarithmic equations and exponential form of the equation. So number 1 was log base 5 of 3x minus 4 equals 3. And I like that 3. I like that circle. So I'm going to start at 5, go to 3, and at 3x minus 4. And so that becomes, right, is 5. We're going to circle. To the third power is 3x minus 4. Good? Now we can solve. 5 to the third power is 125. Good? I'm going to add 4 to 125 to get 129. And then I'm going to divide 129 by 3 and get 43. Good. I can go back and I can put that into my equation to check it. So I will check it by typing in log. Well, I'll just do it right here. Log base 5 of 3 times 43 minus 4 is 30. Good. Now let's do number 2. Number 2 is the log base x of 81 is 2. All right. Log of the base of x, 81 equals 2, is, I'm going to do the circle. Start with base x to the power of 2 is 81. X to the power of 2 is 81. And now we're just going to solve it. Okay. X squared equals 81. Like one step. That one step would be square root both sides, right? The square root of x squared is just x. The square root of 81 is a 9 as its principal square root, but we also know that negative 9, right? If I took negative 9 and squared it, I could get 81. Right. All right, let's check our answer. So we say x is 9 and x is negative 9. So the log of 9, log base 9 of 81 is 2. And if we think about it, negative 9. Yeah, negative 9 should work, right? negative 9 times negative 9 is 81. Yeah. All right. Log base negative 9 of 81 is a non-real answer. So remember on our first page, it said, you cannot take the log of a negative number. So negative 9 is not a possible solution. X is only 9. Good? Then looking for our calculator will always tell us when we've done that. Now we are going to solve exponential equations by converting them back to, sorry, number 3, e to the power of 3x equals, that's very difficult, right? Nowhere else. So we say is, and we use log. We'll go in a circle. Right? E log base e of 7 equals 3x. So we're supposed to log, start at the base e of 7 equals 3x. Log base e, remember we learned, is natural log. So you want to find ln on your calculator and use that one to solve this. Log e is the same as ln of 7. Good. Before we put that into our calculator, I would just finish solving for x. So natural log of 7 equals 3x. I'm going to divide those x by 3. So I get natural log of 7 divided by 3 is x. And then I can just put that, I can either leave it like that if they want to make the x answer, or I can say x is, and I can say natural log of 7 divided by the natural log of 3 is 1. Sorry, it was not 3 natural log 3, it's just regular 3. I thought it was ln 3. So that way you have it was log. It's a natural log, but it had to be. That's wrong, guys. Log of 7, natural log of 7 divided by 3 is 0.6486. 367164. So if you want an exact answer, you just give them that. If they want a rounded answer, you say 0.649. I'll tell you when to stop. Okay. Ooh, and we should put that. We should check that, right? I'm going to use my exact answer and see if I can use that solution. So e of x, I'm typing that 3 times natural log of 7 divided by 3, and I get 7. And you can kind of see that, right? Because it's like, well, here's this is undoing this part, and then this is undoing this part, and then I'll go that. Kind of see. All right. And our last one, number 4, is e to the power of 2x plus 5 is 8 becomes, we're going in a circle, log e of 8 equals 2x plus 5. Log e of 8 is 2x plus 5. And what we will practice up here is log e translates to natural log of 8 equals 2x plus 5. Good. We're going to subtract 5. We're going to say natural log of 8 minus 5 equals 2x. We're going to divide by 2 and say the natural log of 8 minus 5 divided by 2 is x. Good. Natural log of 8 minus 5 divided by 2 is negative 1.460 279 229. And I check that. So e to the power of 2 times natural log of 8 minus 5 divided by 2 plus 5 is 8. Or e to the power of negative 1.4602792. Ooh, no, sorry. It was 2 times. 2 times. Plus. We've got close to 8. Not exactly. We're rounding that. We'll get close. All right. 4x equals negative 1.463. Okay. Now, let's go back to, before we get to example 6, because it's not in the same theme, let's go back to this original. 2 to the power of x equals 5. Do we know how to solve? Yeah. We just go in a circle. Start the base. So now I have is log base 2 of 5 is, and I can just put that into a calculator. Log base 2 of 5 is 2.3219 28095. Good. And example 6 is just a way to apply both the letter E and how to use an exponential equation in the real world, right? So a model for the number n people in a college who have heard a certain rumor is that number equals P, which is the total population of the community, times 1 minus e to the power of negative 0.15 times d, which when d is the number of days that have elapsed. So in a community of 1,000 students, so P is population, and they said it's 1,000, right? Population is 1,000. In a community of 1,000 students, how many days will elapse? before 452 occurs. D is day, and D is what we want to find. So we need to find D when the whole answer is 4. What is D when n of D is 450? We're just going to put those into our equation right here. We know that P is 1,000. We know n of D is 450, but we need to find this D up here. So n, I'm just going to rewrite the whole thing so that it's super clear. ND equals P times 1 minus E to the power of negative 0.15 D. Good. We know n of D is 450. We know P is 1,000. And we are solving for D. 1 minus E to the negative 0.15. Good. I'm going to distribute. Start by distributing 1,000. So now 450 equals 1,000 minus 1,000 E to the power of negative 0.15. I'm going to isolate E because E is the only thing that has the exponent. The 1,000 is not the exponent. So I'm going to subtract 1,000. $450 minus 1,000 is negative 550 equals negative 1,000 E to the negative 0.15 E. Divide by 1,000. Divide by negative. Negative 550 divided by negative 1,000 is 0.55, right? Equals E to the power of negative 0.15. Good. Now I have an exponential equation with the variable, sorry, an exponential function with the variable in the exponent. What do? I have to convert it into logarithmic form. So E, the negative 0.15D is 0.55 is the same as log base E of 0.55 is negative 0.15D. Log of E becomes natural log. Natural log of 0.55 is negative 0.15. Now I just keep going, solving for E. My last step would be divide both sides by negative 0.15. And I get the natural log of 0.55 divided by negative 0.15 is because this is a word problem, I wouldn't leave it in its most accurate, precise answer. I would simplify it. So we have the natural log of 0.55 divided by negative 0.15. And my answer is 3.9. And if I rounded that, it'll be 9, right? So it'll be about 4 days. So I'd say about 4 days. Or 450 out of 1,000 people here. Right? And that is the last example. So now you know how to convert between logs and exponents, evaluate logs and evaluate exponents, and even solve real world problems using that include exponents in variables in exponents. You know how to solve when you have to find the value of the exponent, and it's not a simple exponent that you just know in your head, like 2 to the power of 3 is 8, right? Okay, excellent work, and I'll see you next time.